Triangles, just basic triangles. Just finding sines, cosines, tangents. Basically, it wants all 6 trig functions. I think you could do this without. You guys could do the lecture, I think. So here's our angle theta, right up there. And they want me to. They're starting with the sine of theta. So they want me to find the sine of theta. How do you find the sine of theta? Yeah, remember the SOHCAHTOA? Right, remember SOHCAHTOA? SOHCAHTOA. So what is sine? Opposite over hypotenuse. Now, how do you know opposite hypotenuse and all that? Well, they're giving the angle theta up there at the top. They could have put theta anywhere. But from theta's perspective, which side is the opposite side? B is the opposite. A is the adjacent. And over here is the hypotenuse. Are we good with that? Remember how to do that from your trig days? Triangles. Right, so there's angle theta. What's next to it is the adjacent. Across from it's the opposite. And the longest side is always the hypotenuse. The side not touching the right angle, huh? Okay, now how do we... They're telling me A is 13. This side is 13. B is 8. Write that a little better. How do I find the hypotenuse? The pythag. Yeah, exactly. Everybody good with that? The pythag. A squared plus B squared is C squared. So 8 squared plus 13 squared is C squared. What is that? 64 plus 169 is C squared. What is that? Somebody have a calculator? 234? 233? Yeah. 233, root it. So this is the root of 233, which is not a clean number. Let's leave it like that. All right, so then what is the sine of theta? Opposite, 8 over hypotenuse, root 233. There it is, except you can't leave a root in the bottom. You remember that whole rigmarole. So we got to basically multiply top and bottom, don't we? Kind of out of room here. Let me move this over. Maybe I should have done it over here. So that was 64 plus 169, 233, root it. Okay, anyway, so multiply top and bottom by root 233. And you get 8 root 233 over plane 233. So there's sine. Let's find cosine. What's the cosine of theta? Yeah, adjacent over hypotenuse, right? Adjacent over hypotenuse. Adjacent is the 13. Over the hypotenuse, root 233. So these are like easier versions, bless you, of the little triangles you already have to do in the coordinate systems, huh? These are like easier versions. Multiply top and bottom by root 233, and you get 13 root 233 over plane 233. I'm not going to, tangent, you could do all the rest, right? And then tangent would be opposite over adjacent, right? TOA. And then the other three, you just flip it, don't you? For, what is it called? Cosecant, secant, and cotan. Good enough for number 1? Remember that? Yeah.
Could you just do like maybe secant or cosecant, because if you flipped it, you would have another.
Yeah, good point. Yeah, if I was to do like cosecant, which is the upside down of sine, rather than flip this one, rather than flip the final answer, which would put a root on the bottom, I'll flip the one before I simplify it. It just saves some time. Good point. That is a good thing to think about and just do ahead of time. Yeah. So I would just flip that one. For secant, again, I would flip the cosine while I still had the root in the bottom. That would put the root on the top, so I won't have to mess around with simplifying. And then tangent, I'll opposite over adjacent, so that'd be 8 over 13. Cotan then upside down, 13 over 8, done. All 6. Good? It's your favorite section? 4, and it wasn't the hardest thing in trig. This will complete our review of trig here. All right, Solve the triangle. They're saying solve the triangle. What do they mean, solve the triangle? They mean find all the sides and all the angles. All the sides and all the angles. So, how do we do it? Well, they're telling me already B is 6 and beta is 50 degrees. Beta. Notice how they use Greek letters for the angles. It's pretty common. Take physics or higher math, calculus. Often they'll use the Greek letters for the angles and the English letters, A, B, and C regular for the sides. I still remember when I took physics. And I took it in high school, and the teacher, Mr. Grimes, he wrote on the board, it's like the first couple of weeks of class, he wrote this on the board. What is that? That's just A squared plus B squared is C squared, but with Greek letters, right? Alpha, beta, gamma, instead of, But it confused me, not just all semester, because high school, is a year. All year, I was confused by that. I remember he brought it up several times, and I'd always be like, what is that? What is that? I was such a weird little kid that I didn't I guess I was just scared. Just go up and ask him. I mean, it's just crazy as I look back, like, what was I doing? Just go on up, say, Mr. Grimes, what is that thing? And he would probably hit me upside the head, say, you dummy, get out of here. No, he would have explained it to me. It's just Greek letters. So funny, I was confused by that, like all year long. So anyway, just Greek letters, same as English letters, doesn't matter, right? No one's confused. All right, so onward we go. So how are we going to solve this triangle? How are we going to find all the angles, all the sides? Idea?
Don't all the angles in a triangle equal 180?
Very good. 180, right? Remember triangles, all triangles, total 180. Bless you. And what do we got there? 90 already. So the other two got to make 90. So we can find alpha because we got beta as 50. So if you take 90 minus 50, you'll get 40, and that must be the alpha. Right? So now we got all the angles. Now we just need to move our attention to the sides. Yeah, good job. That's the first thing. Find the other angle by subtracting from 90. Okay, so let's find the side now. So let's find side A here. How do we find that little a? What do we do? Yeah. Tangent would be a great idea. Yeah, tangent's a great idea. And why tangent? You want something that relates 50 degrees with the 6 and the A you're looking for. Now, we could have done the 40 degree. There's no magic here. That would have been okay, too. Yeah, so ask yourself, what trig relate... In other words, what you don't want to use. What you don't want to use is this C. Because I don't know C. So, for example, I don't want to do... What would that be? Cosine. I don't want to do cosine of 50. Why not? If I did cosine of 50... Remember what cosine... Remember SOHCAHTOA? Let me write it up here again. SOHCAHTOA... Cosine is adjacent over hypotenuse. That would be adjacent, little a, over hypotenuse. See, I wouldn't know either one of those. I'd have two unknowns. I can't do anything with that. You see the problem? Right? This is the adjacent side. This is the hypotenuse. This is the opposite side from the 50-degree angle's perspective. It always matters which angle you're talking about. His perspective, who's opposite and adjacent and hypotenuse. Right? You good on that? So from the 50-degree angle's perspective, it would not pay to do cosine. Does everybody see that? So you do have to be a little thoughtful about which angle you use. You want to say to yourself, okay, I need to use the number I know. I got a 6. I got to use that. So what will involve the 6, the A, and the 50? That's opposite and adjacent. What's opposite and adjacent? Tangent. He's got opposite and adjacent, huh? See how we're coming up with that? So tangent then of 50 will be opposite over adjacent, 6 over the little a, right? That's opposite adjacent, 6 little a. Okay, so what? Well, now I can solve that equation for little a. How do you solve that equation for the little a? Thought you would all say it together in chorus. Like the Von Trapp family singers for the Sound of Music. Just singing out. No, sorry, I'm just imagining crazy stuff. All right, but you put this over 1, make it look like a fraction, and go diagonal, diagonal, right? Remember we got fraction on one side, whole number thing on the other, put it over 1, diagonal, cross multiply. So a tan 50 is 1 times 6. Is that good? So a tan 50 is just 6. 1 times 6 is just 6. How do you solve for little a now? Just divide by tan 50. Boom, little a's alone, hit the buttons. I don't got my calculator. So anybody got that one? Make sure you're in degree mode. We were in radians earlier, but 50 degrees, right? So make sure you're in degree mode. So 6 over tan 50, somebody got it? Can I borrow a calculator? Can I? Thank you. 6 over tan 50. Check your mode. Go to degree. Everybody know where the mode button is, or at the top, right? So go into mode, make sure you're there, into degrees. And I'm getting a 5.03. They want 2 places, hundredths place, so 2 places. 5.03. So this side is 5.03. We got the little a. Last thing, so we're supposed to get all the sides, all the angles. What do we got left? We got to get the c over here. Only thing we need is c squared. Now, I could do a squared plus b squared is c squared, but that wouldn't be wise at this point because of rounding issues. If I did that, I would have to use the 5.03, which is a rounded number. Remember, you never want to use a rounded number to do something else with because it'll make the final answer too far off. So it would be better. I mean, if you could just use it. If you wanted, you could do it, but you'd have to use more accuracy than just 2 places. If you want the final answer for c squared to be accurate to 2 places, then you got to use more than 2 along the way. Does that make sense? So if I wanted to make it, so it's actually 5.03, what, 4, 5, 9, 7, 7. I want to throw that many in there, then yeah, that'll work fine. That you could just do that. But I think it would be easier just to say, hey, why don't I just find the c by just using stuff that's, not rounded. Like, again, using the 6. That'd be easier. How could I use the 50 and the 6 and the c? That's opposite and hypotenuse. What's opposite and hypotenuse? Yeah, sine, huh? Am I going too quick? Everybody see that? So the sine of 50 will be 6 over c, opposite over hypotenuse, huh? That way I don't got any rounded numbers. I just got a straight 6, and I don't have to worry about all that rounding stuff. How do you solve that? Over 1, diagonal, diagonal. Same thing. C sine 50 is 1 times 6. C sine 50 is 6. Last step, divide by the sine of 50. Boom. Hit the buttons on the calculator. Where is the sine? Sine 50. I'm getting 7.83. 7.83. So we solved the triangle. We found all the sides and all the angles just using SOHCAHTOA. Nothing new to you, huh? You could have done that lecture, right? All right, good? Remember that from your trig days? Questions I can answer? Onward, Dave. Same thing, triangle, they want all the sides, all the angles. They're giving me A is 6, B is, or C is 7. Can you find the other side? Yeah, go ahead and find the other side. Fag, right? Pythagorean theorem, A squared plus B squared is C squared. You got 2 sides. So I'll do that. A squared plus B squared is C squared. So 6 squared plus B squared, is 7 squared. 36 plus B squared is 49. Subtract 36. B squared is what, 13, root 13? I'm just going to leave it root 13. Rather than like a rounded number, I don't want to round anything. I could always figure out what the decimal is later. Whatever it is. What is it? 3 point something? But anyway, I'm just going to leave it root 13. So we got that side. Now, that's new, nothing, no surprise there. But now comes the new part. How do I find the angles? Do you see the difference between this problem and the last one? They're not giving me any of the angles. See the issue? Last time they gave me one of the angles, didn't they? And so I just subtracted from 90, right? Because I still have the 90. I still have the right angle. But I don't have either one of the other two. You know what I mean? Let's look back to the last problem if I'm not making sense to you. See back here? It looks terrible now. It's all scribbly. Back here, see how from the beginning they told me beta was 50. They gave me one, and so then it was easy to subtract from 90 and I found the alpha, huh? But now, they're not giving me any angles. That's what's new about this. We're going to have to do something special. How are we going to find the angles? What's that? Not radians. How about, let's set, oh, you guys are wanting to do fancy stuff. How about we just set up another SOHCAHTOA? It's just SOHCAHTOA. This whole section is just SOHCAHTOA. So don't worry about laws of sines and cosines and other fancy stuff. I promise SOHCAHTOA will handle this whole section. So let's just think about SOHCAHTOA and whatever you want. How about, why don't I go for beta first off? You can start with alpha, doesn't matter. Let's start with beta. And how about I use the 6 and the 7? You could use the root 13, but I'll just use the 6 and 7. So I'm looking at it and saying, okay, I want to use beta and the 6 and 7. What trig, sine, cosine, or tangent relationship involves beta, the 6, and the 7? This is the hypotenuse. This is the adjacent side to beta. It's next to beta. It's touching beta, right? This is the opposite side from beta. It's across from beta. So what trig relationship involves A and H? Cosine. A and H. So that means the cosine of beta is 6 over 7, right? Adjacent over hypotenuse, 6 over 7. Good so far? Okay, so what? Cosine of beta is 6 over 7. What am I going to do with that? How do I find beta?
Just use the inverse cosine.
Inverse cosine, right? Because I'm trying to solve for beta, and it's in the toaster, right? I don't divide by cosine there to get beta alone. To get beta alone, I don't divide by cosine. Here we go, the toaster talk again, right? Because that's not multiplication. That's not cosine times beta. That's cosine of beta. Beta's in the toaster. So whenever something is in a function of any kind, log, exponential, sine, cosine, tangent, it's going to have tons of this if you go to calculus. Whenever something's in a function and you want it out, how do you get it out of the toaster? You do the inverse function. To both sides, right? That's why we have inverse functions, because they get things out of the toaster, which we need to do all the time going forward in math. So I'm going to do inverse cosine on both sides, and then these guys cancel and pop. Out comes the beta out of the toaster. And so what's the other side? Inverse cosine of 6/7. Hit the buttons on your calculator. Make sure you're in degree mode, because I want degrees on this one. So on my calculator, actually, it's not my calculator. This calculator is saying 31.00 degrees. They want it 2 places. Hundredths, right? I got 31.00 degrees for beta. Did your calculator tell you the same story? Good, good, good. Let's get alpha now. How do we get alpha? The 90. Subtract from 90, right? 90 minus 31.00, whatever that is, 59 degrees. Done. So y'all see how to do that? Does that make sense then? How you solve these triangles where they don't give you any angles? Is that good? Is that wonderful? Questions on that?